Hello, this is a video on how to calculate poker hand probabilities. And one of the reasons I did it, I have a playlist called Combinatorics. And there's only 4 videos in it. And so I want to start adding different results that involve combinations, permutations, combinatoric type stuff. And poker hand analysis fits right into that. And so let's just jump right in. And so first, the total number of 5-card hands is, I think, pretty commonly known. You have 52 cards. We want to randomly choose 5, and order doesn't matter. And so we use combinations. And so there's 2 million, over 2 million number ways to pick 5 cards. And so what we do in the next 10, there's 10 poker hands, 10 distinct hands. And we want to find the number of ways that those can happen. And then so to find the probability, you take number of ways it can happen divided by the number of 5-card hands. So what I'm actually going to show is the number of ways each of these hands can be drawn, and then leave that probability calculation up to you. So here, the highest hand, the royal flush, is ace, king, queen, jack, 10, all in the same suit. And so in one suit, there's only one way to get a royal flush, and that's this sequence here. But it could have been in any suit. So of the 4 different suits, we have to pick one. And a suit is a heart, diamond, club, and spade. There's 4 different ways. So the number of ways a royal flush can happen is 4. So to calculate the probability, you take 4 divided by this big number. Now, a straight flush is hand number 2. And a straight can be ace, any 5 cards in a row. So, so they have to be the same suit. So, ace through king, it can't be that, because if they're in the same suit, then it's a royal flush. So we have to start with king through 9. So there's 1 way, 2 ways, 3, 4, and there's 9 different ways that you can have a straight in the same suit that's not a royal flush. Okay? So the way to calculate this is you randomly pick a suit. So 4 choose 1. And then you randomly pick one of the 9 different ways to have a straight. And that's 9 choose 1. So there's 36 different ways to have a straight flush. Now, this is the way I think about it and calculate it. And the way you'll see it in books is the following. So here it's number of ways to pick a suit, and then the number of ways to pick a straight. Now, if you add this 10, or the ace to be, this straight, and then go down, then there's 10 ways to choose a straight, and that's what this is. Pick a suit, pick a straight, but this includes royal flush, so you have to subtract out royal flush, and you get 36 both ways. And to me, this is a much cleaner way to think about it, but all of the books have it this way, so I want to show that. So now, in every hand that follows, we're going to use this grid. So this is for 1 suit, and then there could be 2 suits, 3, 4. So think of it as 4 rows, and then without this ace, 13 columns, okay? And we're only going to bring the ace to the high when we think about this probability of a straight again. And that's hand number 6. So in what follows, think about 4 rows representing the 4 suits and 13 columns representing the 13 numbers, okay? And the reason that we do this, in my only analogy, and it's similar, when the classic problem of, you have so many shirts, so many pants, so many shoes, how many different ways can you dress? You don't do it this way. You don't say, what's the probability I pick a shirt, and then you say the probability I pick a pants, but then assuming that I didn't pick these other shirts, and then assuming I didn't pick the shoes, and then what's probably I pick a shoe and not these shirts and pants again. I mean, you can do it that way, but it becomes ugly. What you do is you group all the shirts together, group all the pants together, group all the shoes together, and then the number of ways you can pick a shirt times the number of ways you can pick a pants, number of ways you can pick a pair of shoes. That's the number of ways for different, outfits. And so we're going to have to think about it like that. So this 4x13 grid, what we're going to do is we're going to grab certain pieces and isolate it, separate it. It'd be like grabbing the shirts and putting them over here, and then finding the number of ways you can, you can wear a different shirt, and then times the probability of what's left. And so as we go through, think about it that way. So here we have 4 of a kind, and 4 of a kind means 4 of one number and then another card. Okay, so here, remember the grid. So of the 13 columns, let's pick one of them. And now let's take that and set it aside. So we've just picked our 4 of a kind. And then we need another card. So there's 48 cards left, we want 1. And so that's it. That's the probability. That's 624 different ways to calculate a 4 of a kind. Okay. Now I'm going to show you this next way to calculate it, because this is what you see in books, and this is actually will help us in the remaining hands. Okay. It's this. They're the same. Of course, they have to be the same. But here, randomly pick a column. So we take that and set it aside. Then we randomly pick another column, but we have 4 cards. And so what's the number of ways we can pick one of those 4? Well, it's 4 choose 1. So then, then all the other cards, we want 0 of them. So there's, those don't factor anymore. And so this times this is the probability. So it's 624. Okay, so now the probability that we have a full house, that's 3 of one suit and 2, of a number, and 2 of another number. So 3 and 2, called a full house. So what we do is this one is the number of ways to pick 3, and this is the number of ways to pick 2, and we don't care about the other cards. So the way that you think about it is you randomly grab a column. So we randomly pick 13 choose 1, so now we have those 4 cards and we set them aside. And then of the 4, we only want 3. So this is the number of ways to pick 3 cards of the same number. Now here, so there's 12 columns left. We want to grab one of them randomly and then set those aside, but we only want 2 of the 4. So this product is the number of ways a full house can occur. A flush is 5 cards of the same suit. Sans a straight flush and royal flush. Sans means except. So we want a flush, sans a straight flush and royal flush. We can't count those in our flush, because if it's a royal flush, then it's it's the best hand in poker. So this is the way I think about it, and then I'll show you the way that a lot of the books have it. So here we want a flush, so it's 5 cards of the same suit. So we randomly pick one of the rows, right? So now 4 choose 1. So now we take those 13 cards of the same suit, and we only want 5 of them. So 13 choose 5. So this is a number of ways to pick 5 cards of the same suit. But we have just included in that the probability, or the number of ways a straight flush can happen and the number of ways a royal flush can happen. So we have to subtract those out. And that's 5,108, okay? But this is what you'll see in most books. So this first way to think about it's the same, but we just subtract out this. So it's 4 choose 1, 10 choose 1. And this is the number of ways to have a straight flush, including a royal flush. So those 2 actually add to this. Now a straight is 5 cards in sequential order, and but they can't be all the same suit. Okay, so we want a straight, sans a straight flush and royal flush. So this is the only way where we have 4 rows, but we have 14 columns, because the ace can be a low or a high in a straight. So this is the way we think about it. So here, there's 10 ways to have a straight. Okay, so of the 10 ways that you can have a straight, we want only one of them. Now, once we pick one of those straights, so this is picking all those columns. So if you think about the top row, and then the sequence can only be these 5, these 5, these 5, these 5. There's 10 different ways to pick a straight. We want one of them. So now what we've done is taken the whole columns and rows and set them aside. Now here, for the first number in the sequence, we only want one of the 4. And the second card, we only want one of the 4. We have to do that for all 5 cards. We only want one suit, but we may have picked all the same suit. So we have to subtract out the probability of a straight flush and a royal flush. And then that's it. So that's 10,200. And in the books, you'll see it this way, because those two added together is this. Now, 3 of a kind is 3 of one number and then 2 different numbers, not of the same 3. Okay, so again, think about it as separating the shirts, the pants, and the shoes. So here, we're going to separate the 3 of a kind. So of the 13 columns, we want 1. So we take that column and set it aside, but we only want 3 of the 4. So this is the number of ways to have 3 of a kind. Then here, we want 2. We randomly pick 2 more columns. That means 2 different numbers. But in the first column, we only want 1 of the 4, and the second column, we want 1 of the 4. So this is the number of ways to have 3 of a kind. Now we're 2 pair, self-explanatory. We had 2 of the same number, 2 of the same number, and 1 of a different number. And of course, this pair and this pair have to be different. So what we do is here we randomly pick 2 columns of the 13, but in the first column we only want 4 or 2 of the 4. In the second column we only want 2 of the 4. Now so that's 4 cards, and then the last card we want to pick 1 column, but we only want 1 of the numbers in that column. So this is a number of ways to do 2 pair. 1 pair is similar. So we randomly pick 1 column, but we only want 2 of the 4. And then we pick 3 more columns here, and then we only want 1 card of the 4 in each of those 3 columns. So this is the number of ways 1 pair. Now high card, that means that we have 5 different cards, and they don't fit in any order or ways of the first 9 hands. Okay, so there's 2 different ways to calculate this, and both I've seen in books, and so we'll do it both ways. And the first one is there's 52, choose 5 different ways to have a poker hand, and we subtract out the number of ways of the first 9 hands. So add them all up, subtract it from 52, choose 5, and that's your answer. Okay, and that's a pretty easy, straightforward way. But since the idea here is to learn combinations, let's do it the much longer way. So here, we want to randomly pick 5 columns. And so that gives us 5 different numbers, because we've picked 5 columns. But in each of the columns, we only want to choose 1 of the 4. And that's what this represents. So now we have 5 different numbers, and we have only 1 card of those in those columns. But With 5 different numbers, we could have randomly picked all the same suit. So we have to subtract out the number of ways to get a flush. Or we could have picked these 5 in a row with different suits. So we have to subtract out the number of ways to do a straight. And then we have to subtract out the number of ways to do a straight flush. And then the number of ways to do a royal flush. And then this is it. This is the probability. So again, this comes down. This is a flush. This is a straight. And this is the combined straight flush and royal flush, which then of course equals the same probability or the same number of ways as we did. Well, that's all I have for today. Hopefully you enjoyed it. I sure did. Like it if you did, and subscribe so you don't miss the next one. Thanks. Bye.